Right now, beneath the border of France and Switzerland, physicists are accelerating the fundamental building blocks of matter to, well, about 99.9999% the speed of light.
It is incredibly fast.
Yeah, and they smash these protons together in the Large Hadron Collider, looking at the debris to try and understand the universe. But, I mean, here is a secret that theoretical physics rarely says out loud. We might be completely fundamentally wrong about what those particles actually look like right before they crash.
We really might be.
Because if you picture a proton as a tiny, hard billiard ball flying through a tube, you are not alone. I mean, that is how it's taught, right?
Exactly. It's the classic textbook image.
But today, we are tearing into a stack of radical theoretical physics papers. Specifically, we're looking at the Redefined Mass framework by Vrbovsky-Banić. Our mission for this deep dive is to explore a framework that suggests particles physically transform their geometry near the speed of light. We are going to look at why string theory might not need any extra hidden dimensions, and how the violent shattering of these particles could, answer the biggest mysteries in cosmology.
It's an incredibly ambitious framework.
It really is. We are talking about demystifying dark matter, finally explaining magnetic monopoles, and realizing that everything we call an exotic particle might just be a frozen crack in the quantum vacuum. So if you are listening to this right now, buckle up.
The shift in perspective we are discussing today is profound. I mean, for the better part of 40 years, high-energy physics has relied heavily on highly abstract mathematical spaces. When equations yielded infinities or paradoxes, the standard approach was, often to invent invisible placeholder particles or add extra dimensions to the math just to force it to work.
Right, the whole math first, reality second approach.
Exactly. Banić's framework does the exact opposite. It takes those abstract, purely mathematical concepts and roots them entirely in physical electrodynamic geometry. So we are moving from the dizzying, untestable math of higher dimensions into a tactile, mechanical model of a three-dimensional universe.
So if you are walking the dog or driving right now and you're picturing a 10-dimensional universe, you can just throw that out the window for this conversation.
Yeah, totally unnecessary here.
We are grounding everything in the 3D space we actually live in. But to get there, we need to start with the basics. Standard physics, specifically the Standard Model, treats particles like electrons or quarks essentially as point-like objects. They are treated as zero-dimensional mathematical points.
Or at best, a perfect little sphere.
Right. When we talk about a proton, we talk about a perfectly spherical little blob of mass and charge. But this redefined mass framework argues that we need to stop thinking of particles as solid objects with hard physical boundaries.
Because treating a particle as a zero-dimensional point is just a mathematical convenience.
Sure, it makes the math easier.
It makes the calculus so much easier when you don't have to worry about the actual volume of the object you are studying.
Yeah.
But physical reality doesn't deal in mathematical conveniences. Banić's framework insists that a particle's physical boundary is not a hard shell, like, say, the plastic of a ping-pong ball.
Okay.
Instead, the boundary is held in a dynamic equilibrium. Is a constant, unending tug-of-war between two fundamental forces. On one side, you have outward electrostatic repulsion. Because, a proton has a positive charge, right? That charge is constantly trying to repel itself, essentially trying to blow the particle apart.
And if that was the only force, the proton would just explode into the vacuum.
Instantly.
So there has to be a counterforce holding it all together.
Yeah, and that counterforce is the inward pressure of its own self-generated magnetic field. Even at rest, the internal dynamics of the particle generate magnetic confinement. So a proton is a perfectly balanced sphere of outward electrical pressure and inward magnetic pressure. It is a dynamic bundle of energy.
Okay, that makes intuitive sense to me. But things get complicated when that bubble starts moving, right?
Very complicated.
Because when we take that proton and accelerate it in a collider toward the speed of light, when its velocity, which physicists denote as v, approaches the speed of light, the sources state that this moving charge generates a massive azimuthal magnetic field.
Yes.
Let's break down azimuthal for a second. If I have a straight wire and I run an electrical current through it, the magnetic field doesn't point perfectly forward or backward.
No, it wraps around.
Right, it wraps around the wire in circles.
That is the perfect visualization. Now replace that wire with a single proton flying down a beamline.
Okay.
As it moves, it generates a magnetic field that forms concentric circles around its axis of motion. And because this field is cylindrical, wrapping around the axis, the inward magnetic pressure pushing against the particle's boundary is no longer uniform.
It gets
It
weird.
becomes highly asymmetric.
Uh,
The faster the particle moves, the stronger this magnetic field becomes, and the more asymmetrical the pressure gets.
Now, the papers go into some heavy mathematical derivations here, specifically referencing something called Vrbovsky's magnetic theory of kinetic energy. They state that this inward pressure is proportional to the sine squared of the polar angle.
Right.
Let me see if I can map out what that actually means mechanically for you listening. The polar angle, which we call theta, is measured relative to the direction the proton is flying. So if the proton is flying dead ahead, the absolute front of the proton, its north pole essentially, is at an angle of 0 degrees.
Exactly. And the sine of 0 degrees is 0. Therefore, sine squared is 0.
Which means at the front pole, and I guess by the same logic, the back pole, the inward magnetic pressure is absolute 0.
None at all.
The magnetic field is completely ignoring the front and back of the particle. Nothing is pushing in on it longitudinally.
But look at the sides. At the equator of the proton, the area perfectly perpendicular to its direction of motion, the polar angle is 90 degrees. The sine of 90 degrees is 1. Sine squared is 1.
Which is the maximum.
It represents the absolute maximum. At the equator, this inward radial magnetic pressure reaches its peak. And as the velocity v approaches the speed of light c, that maximum inward pressure scales up exponentially.
Wow.
It actually approaches infinity.
Let's put a physical image to this. Imagine you are holding a water balloon, and that balloon is our proton. If you wrap your hands right around the middle, the equator, and you squeeze as hard as you can, you aren't pushing on the top and you aren't pushing on the bottom. You are only applying radial pressure to the center.
Right.
The middle of that balloon gets incredibly thin, and the water is forced to bulge out toward the ends. Only in a particle accelerator, you aren't using your hands. The proton is being squeezed by its own massive self-generated magnetic field.
Under this framework, as v approaches c, this intense inward radial pressure at the equator literally crushes the three-dimensional spherical mass shell.
It just crushes it.
Completely. The dynamic equilibrium we talked about is broken. The outward electrostatic force is completely overwhelmed by the inward magnetic pressure at the equator. The proton flattens radially and stretches longitudinally. It physically collapses from a 3D sphere into a one-dimensional string.
Okay, I need to stop and push back on this for a second, because anyone who has taken a college physics course on special relativity is probably yelling at their device right now.
Oh, I'm sure they are.
We are taught about Lorentz contraction. The hard rule is that as objects move close to the speed of light, they flatten in the direction of motion. If I am flying forward at 99% light speed, an observer is supposed to see me squished like a pancake from front to back, not squeezed from the sides.
Right.
This framework is arguing the exact opposite of Lorentz contraction. It says they collapse transversely and stretch out.
It is a staggering departure from textbook relativity, but the authors of the framework address this head-on. The standard Lorentz contraction assumes that we are dealing with rigid bodies moving through an abstract space-time grid. It is a purely geometric assumption.
Okay.
But Banić argues that a particle is not a rigid body. It is a physical boundary held together by real electrodynamic forces. When you map the actual electrodynamics, specifically the magnetic pressure equations governed by that sine squared theta rule, the physical forces demand a transverse collapse.
Because there is literally zero force pushing on the front of the proton to pancake it.
There is zero magnetic pressure at the poles, so there is no mechanism to squish it longitudinally. The entire crushing force is concentrated on the equator, driving the transverse radius asymptotically towards zero. And, the kinetic energy you use to accelerate the particle is not just some invisible abstract property. In Vrbovsky's model, that kinetic energy is physically stored in the magnetic field generated by the moving quarks. That energy physically restructures the proton into a highly tensioned one-dimensional string aligned with the axis of motion.
So we are replacing abstract geometry with actual fluid and electrodynamics. We are taking a hard spherical proton and realizing it's a bubble that crushes itself into a needle based on how fast it flies through the vacuum.
Exactly.
But, the moment we introduce the word string into high-energy physics, we drag in decades of mathematical baggage. When physicists talk about string theory, they're usually talking about invisible, curled-up dimensions.
Yeah, string theory is famous for that.
They talk about 10-dimensional space, 11-dimensional M theory, or 26-dimensional bothonic string theory. If our proton has collapsed into a string, where are all the extra dimensions?
This is one of the most elegant and arguably controversial resolutions in the entire Banić framework. The answer is that we don't need them.
Wait, really?
Yeah, the extra dimensions are mathematically obsolete.
That is a massive claim. Entire careers, research grants, and institutes have been built on Calabi-Yau manifolds and 11-dimensional math. How does this framework justify completely killing the need for extra dimensions?
Well, to understand the solution, we have to look at the history of why string theorists felt they needed 10 or 26 dimensions in the first place.
Okay, take us back.
When string theory was being developed in the late 20th century, physicists made a foundational mathematical assumption to simplify their equations. They assumed that a fundamental string had an absolute transverse width of true zero.
They made it infinitely thin.
Yes, they treated it as a perfect, idealized mathematical line with absolutely no physical thickness whatsoever.
And anytime you assume absolute zero or divide by zero in physics, the math tends to punish you for it.
It really does. This zero-width assumption created massive mathematical roadblocks known as ultraviolet divergences, or UV divergences. In quantum mechanics, to figure out what a particle is doing, you have to calculate all the possible paths it can take.
Yeah.
This is called a path integral over the string's world sheet.
Right.
But when you calculate the vibrations of a string that is infinitely thin, the energy equations spiral out of control. The probabilities become infinite.
And you can't have an infinite probability or infinite energy in a real physical system.
You cannot. These infinities broke a crucial mathematical property of the theory called conformal symmetry. Conformal symmetry essentially means the physics should look consistent regardless of the scale you're looking at.
Okay.
When this symmetry breaks down because of these infinities, it creates a fatal mathematical flaw known as the Weyl anomaly.
The Weyl anomaly.
Right. The theory was mathematically broken. But physicists realized a theoretical workaround. If they injected extra mathematical dimensions into the equation specifically, raising the dimensions to 10 or 26, the negative energy contributions from those extra dimensions perfectly canceled out the positive infinities.
Oh, wow. So the extra dimensions were essentially a mathematical band-aid.
Pretty much.
They weren't discovered by looking through a telescope or smashing particles. They were reverse engineered to fix a math error that was caused by assuming strings are infinitely thin in the first place.
It was a brilliantly clever mathematical fix, yes. But Banić's framework argues it was a fix for a problem that doesn't actually exist in nature. Under the Redefined Mass framework, our string is not some fundamental, idealized mathematical line. It is a crushed physical proton.
And because it's a crushed physical object, it can't be infinitely thin.
Right. Its transverse radius, which the papers denote as a perp, never reaches true mathematical zero. As it gets crushed by that azimuthal magnetic pressure, the internal energy density of the string skyrockets. Eventually, it hits a physical subquantum cutoff limit.
A physical limit.
Yes. The text specifies this physical cutoff is roughly 10 to the negative 18th meters.
Which is unimaginably small, but crucially it is not zero.
Exactly.
But what physically stops it from getting crushed smaller than 10 to the negative 18th meters?
The limit is maintained and regularized by vacuum polarization.
Vacuum polarization.
Yeah, as you compress the magnetic field lines tighter and tighter, the energy density gets so extreme that the vacuum of space immediately surrounding the string begins to polarize. It essentially generates a counterpressure of virtual particles that physically halts the collapse.
So the string retains this tiny non-zero width. How does that fix the math without needing a 10th dimension?
Because it retains a physical width, the path integrals over the world sheet are naturally regularized. In technical terms, the Green's function propagator along the string no longer diverges at coincident points.
Okay, let's translate that real quick. A Green's function is a mathematical tool used to calculate how a disturbance spreads out, like a wave on a string. Diverging at coincident points means the math blows up when you try to calculate the wave's effect on the exact same spot it started.
That is precisely the mechanics of it. When the string has zero width, the wave interacts with itself infinitely strongly. But when you spread that interaction over a finite width of 10 to the negative 18th meters, the infinity disappears.
Just like that.
The mathematical infinities literally never manifest. The UV divergences that break conformal symmetry are physically cut off by the self-energy boundary of the collapsed mass shell.
This makes so much sense. If the Weyl anomaly was the disease and 10 dimensions were the medicine, this framework is saying we never caught the disease in the first place because our strings have physical thickness. We just don't need the medicine.
We don't.
But standard string theory uses those extra dimensions for more than just fixing infinities. Standard M theory says that fundamental properties like an electron's charge, its spin, or its flavor are determined by how the string vibrates inside those invisible, curled-up Calabi-Yau manifolds.
Right.
If those hidden dimensions don't exist, where does a particle store its properties?
This brings us to a beautiful geometric concept. The papers state that those internal properties, charge, spin, flavor, are simply the projected boundary states of the original 3D sphere. Remember, this 1D string didn't materialize out of nowhere. It used to be a 3D proton.
Right, the string has a memory of being a sphere.
A physical memory, yes. When it collapses, it doesn't lose the structural information of its progenitor state. The gauge symmetries, the mathematical rules that govern charge and spin, are fully resolved as the intrinsic boundary states of the collapsed particle. The Weil anomaly is resolved directly in flat, three-dimensional Euclidean space.
Let's ground this with an analogy for the listener. Imagine shining a flashlight on your hand to cast a shadow on the wall. The shadow is two-dimensional. It lacks depth.
Right.
But if you hold up 3 fingers, that 2D shadow carries all the structural information of the 3D hand casting it. You don't need a 4th dimension to explain why the shadow has 3 fingers.
That's a great way to put it.
The 1D string in this framework carries all the properties of the 3D proton it came from. It projects its properties based on its 3D boundary states without needing a magical 10-dimensional room to store its spin and charge in.
It grounds high-energy physics back into tactile three-dimensional reality. I mean, we're utilizing classical electrodynamics at the subquantum level to solve mysteries that have haunted quantum field theory for a generation.
It is a profound simplification. Okay, so we have painted a picture of a stable, physically real 1D string 10 to the negative 18th meters wide, flying down the beamline of a collider at near light speed entirely in normal 3D space. But we don't just accelerate them for fun. We intentionally steer 2 beams of these relativistic strings into each other. What physically happens when 2 of these highly tensioned magnetic needles hit each other head-on?
This initiates what the authors term the string shatter phase. When these strings collide head-on in an accelerator, they experience a violent, almost instantaneous deceleration. In the kinematics of the event, the acceleration vector, denoted as a parta, approaches negative infinity.
They don't just slow down, they hit a brick wall.
They do. And we must remember what was maintaining that 1D string geometry in the first place. It was the intense azimuthal magnetic pressure, which only existed because of their extreme velocity.
Right.
When that velocity drops to 0 in an instant, the self-generated magnetic field vanishes just as fast.
So the invisible hand squeezing the water balloon suddenly just let go.
And this creates a massive, explosive, elastic snapback. All of that kinetic energy, what the framework calls the dimensional reduction energy pool that was physically stored as tension in the compressed transverse plane, is violently released.
Think about stretching a heavy-duty industrial rubber band to its absolute breaking point. It's holding a terrifying amount of potential energy. When you let it go, it snaps back.
With a lot of force.
Exactly. But in this microscopic case, the released energy is so intense it doesn't just sting, it dumps raw energy directly into the surrounding space. The papers detail that this energy spike raises the local temperature to an incomprehensible degree.
The mathematics governing this release are quite specific. The released relaxation energy drives the local temperature far above the critical vacuum transition scale. The paper defines this critical temperature threshold precisely as T being much greater than Tvac, which is approximately 4.58 times 10 to the 14 Kelvin.
Let me just say that number again for you listening. 4.58 times 10 to the 14 Kelvin. We are talking about hundreds of thousands of times hotter than the core of our sun.
It is extreme.
A temperature so high that the very concept of heat starts to lose its meaning. What does a temperature of over 400 trillion degrees do to the fabric of space at the collision point?
It completely vaporizes the local quantum vacuum.
Vaporizes it.
Yes. To understand this, we have to shift our perspective on what empty space actually is. In this framework, the vacuum of space is not an empty void. It is a physical medium, modeled as a virtual Bose-Einstein condensate, or BEC.
Now, a Bose-Einstein condensate is usually what happens when you freeze matter down to near absolute zero and all the atoms blur together into a single quantum state, right?
Yes, exactly.
You're saying the vacuum of space itself is a frozen quantum fluid?
Yes, the baseline state of the universe is a highly structured, superfluid-like condensate. This BEC has a physical ground state density, which particle physicists know as the Higgs vacuum expectation value, or the Higgs VeV.
Okay, the Higgs VeV.
The Higgs VeV is the structured background that interacts with particles to give them their mass. But when this thermal vacuum spike from the snapping strings hits, it is like dropping a thermonuclear bomb into a frozen lake. It melts the condensate.
Wow.
The local Higgs VeV is destroyed, dropping to absolute zero, which is represented mathematically as phi going to zero.
So a collider isn't just smashing two rocks together to see what smaller rocks are inside. For a tiny fraction of a second, the collision is vaporizing the scaffolding of reality. It's destroying the Higgs field in that localized microscopic spot.
By vaporizing the Higgs VeV, the vacuum is forced out of its structured, symmetry-broken state and restored to a perfectly symmetric, massless phase. The stabilizing fluid pressure that gives fundamental particles their physical boundary and their mass simply ceases to exist in that region.
It just disappears.
The authors term this hyperdense, high-temperature region the Higgs symmetric plasma, or HSP.
In this Higgs symmetric plasma, a proton or an electron literally cannot exist, right? Because the physical medium required to stabilize their mass shells has been boiled away.
Exactly. Standard matter cannot exist there. It is a region of pure, unstructured thermodynamic energy. It is a localized phase transition of spacetime itself, reverting back to the conditions that existed fractions of a second after the Big Bang.
That is awe-inspiring. We create a boiling puddle of massless vacuum. But colliders don't melt the world. The collision event is incredibly brief, and the surrounding vacuum is freezing cold. The heat dissipates almost instantly. What happens when this puddle of vaporized spacetime starts to cool down?
As the Higgs symmetric plasma expands outward from the microscopic collision point, it cools back below that critical 4.5, 8 times 10 to the 14 Kelvin threshold. This triggers a rapid phase transition that the authors call a vacuum quench.
A vacuum quench.
Yes. The surrounding structure of the universe rushes back in. The virtual boson BEC scrambles to renucleate and rebuild the Higgs EV. The vacuum desperately wants to freeze back into its normal structured state.
This reminds me of metallurgy or crystal formation. If you cool something down, it solidifies.
It does, but the speed of the cooling is the critical factor here. In thermodynamics, if you cool a system very slowly, it is called an adiabatic transition. The system has time to organize itself perfectly. But this collider event cools incredibly fast. It is a violently non-adiabatic transition. Because the temperature drops so rapidly, the reforming vacuum cannot align its quantum phase uniformly across space.
Let's use an analogy here to make the mechanics obvious. Think about water freezing into ice. If you have a tray of ultra-pure water and you lower the temperature by a fraction of a degree over a week, an adiabatic process, the water molecules have time to find each other, line up perfectly, and you get a beautifully clear, flawless block of ice.
That's right.
But if you flash freeze that same water by dumping liquid nitrogen on it, the water molecules panic. They freeze in place before they can align with their neighbors. You end up with a cloudy block of ice full of structural cracks, bubbles, grain boundaries, and complex fracture patterns.
That is the exact mechanism occurring in the particle collider. But instead of water molecules, it is the quantum phase of the vacuum fluid. As the vacuum flash freezes, these phase mismatches freeze out as stable geometrical flaws in the fabric of space.
Flaws in space itself.
Yes. Postulate 11 of the Banić framework formally defines these physical flaws as topological vacuum defects.
Topological vacuum defects. This is a massive paradigm shift. Because when experimental physicists look at the debris from a collider crash, they detect dozens of bizarre short-lived entities, things they call tetraquarks, pentaquarks, or exotic hadrons.
Yes, the exotic particles.
And the standard model treats every one of these as a new addition to an ever-growing zoo of elementary building blocks.
Banić's framework argues that these exotic particles are not fundamental point particles. They are not new building blocks of the universe. They are literally just the flaws, the cracks, and the bubbles in the refrozen vacuum.
So they aren't particles at all?
No. The papers specifically describe exotic hadrons like tetraquarks and pentaquarks as nested, multi-centered vacuum polarization bags.
Nested vacuum bags.
Yes. They are incredibly complex topological configurations formed purely by the chaotic cooldown of the fluid. Their mass and their brief stability are determined entirely by how their internal fluid fields interfere with each other, a process described mathematically as mutual field interference partitions.
Okay, so when a team at CERN throws a party because they discovered a new exotic particle, this framework suggests they didn't find a new type of fundamental brick. They just found a really complex ice crystal that cracked in a mathematically unique way during the cool down of the vacuum.
It reframes the entire discipline of particle taxonomy. We do not have a messy, infinite zoo of elementary particles requiring increasingly convoluted math to categorize. We simply have different geometrical flaws in a single underlying superfluid.
That is a breathtaking unification of high-energy particle physics and condensed matter physics.
It really is. The vacuum of space behaves exactly like a classical fluid going through a phase transition.
It takes the almost mystical abstraction out of quantum field theory and replaces it with tangible fluid dynamics. If tetraquarks and pentaquarks are the messy defects, the complex fracture patterns in the ice, what about the elegant defects?
It's a stable one.
Yeah, because anytime a fluid undergoes a transition, you can get chaotic ripples, sure, but you can also get perfect self-sustaining structures. The Banić papers talk extensively about two highly sought-after theoretical entities: glue balls and magnetic monopoles. Let's start with glue balls.
Okay.
In standard physics, a glue ball is a hypothetical particle made entirely of gluons. Gluons are the particles that carry the strong nuclear force, the glue that holds protons together. Standard models say gluons could theoretically stick to each other and form a ball with no quarks inside.
Right.
But they've been incredibly hard to definitively prove. How does the Redefined Mass framework view a glue ball?
The framework completely redefines the glue ball as a pure vacuum excitation defect. It is not a ball of little gluon particles bouncing off each other. It is a self-sustaining, closed toroidal vortex ring in the virtual boson BEC superfluid.
Toroidal meaning shaped like a torus or a donut, so a glue ball is essentially a quantum smoke ring.
A quantum smoke ring is an excellent visualization. It is a stable vortex loop. And crucially, it has no central charge shell stabilizing it. A proton has a charge core. A glue ball does not.
It's just empty spinning space.
It is pure vacuum circulation. The velocity field of the superfluid vacuum spinning around the core of this donut must satisfy strict circulation quantization conditions.
Meaning it can't just spin at any random speed. In quantum mechanics, things are quantized and it can only happen in specific, discrete steps.
Correct. The physics governing this spinning smoke ring are modeled using Biot-Savart-line vortex Hamiltonian dynamics.
Okay, I'm going to need you to translate Biot-Savart-line vortex Hamiltonian dynamics for me.
Of course. The Biot-Savart law is a classical electromagnetism equation that describes how a magnetic field is generated by a steady electrical current.
Right.
But in fluid dynamics, the exact same math describes how the velocity of a fluid is induced by a vortex line. A Hamiltonian is just a way to express the total energy of a system. So they are using the classical equations of fluid whirlpools to calculate the total energy of this quantum vacuum ring.
They are literally treating the vacuum of space like water in a bathtub and using bathtub math to calculate a quantum particle.
It's actually yes. And the theoretical derivations they achieve doing this are remarkably precise. The most basic smoke ring, spinning quietly, represents the scalar glue ball. But vortex rings can vibrate.
Like a wobbling hula hoop.
Exactly. The excited spin states of the glue ball are quantized, Kelvin waves bending wave-like harmonics that ripple along the donut itself. The text specifically highlights a state known as the tensor glue ball. This state represents the elliptical quadrupole resonance of the vortex ring.
Elliptical quadrupole resonance, meaning the donut isn't just a perfect circle anymore, it's wobbling. It's flexing into an oval shape, an ellipse, and then flexing back repeatedly.
Exactly. When Banić calculates the energy required for this specific wobbling motion, this quadrupole mode, using pure classical fluid dynamics, the math outputs a highly specific mass equivalent.
What does it predict?
It predicts a mass of 2.48 GeV, which is 1710 MeV.
And for anyone who doesn't memorize particle masses, why is 2.48 GeV a monumental number?
Because that number perfectly matches the supercomputer predictions for the tensor glue ball mass derived from lattice quantum chromodynamics.
Wow.
Lattice QCD is arguably the most complex, computationally heavy mathematical framework in standard physics. It requires massive supercomputers to calculate the interactions of quarks and gluons on a discrete grid.
Right.
To derive a mass of 2.48 GeV using nothing but the classical fluid dynamics of a wobbling vacuum vortex and have it match the multi-million-dollar supercomputer prediction to an accuracy of over 99%, it is a staggering validation of the model.
It proves that you can accurately model incredibly complex quantum fields as a physical, classical superfluid. That is incredible. Okay, so a glue ball is a self-sustaining donut tornado in the vacuum. What about magnetic monopoles.
The Holy Grail.
Yeah, this is one of the holy grails of physics. A standard magnet has a north pole and a south pole. If you cut it in half, you don't get a separate north and south. You just get two smaller magnets, each with their own north and south.
Right.
Physicists have searched the cosmos for a magnetic monopole, a standalone north pole particle, and they have never found one. Does this framework finally give us the monopole?
It does, but it simultaneously explains exactly why standard experimental physics has never been able to isolate one in a detector.
Oh, really?
Yes. The Redefined Mass framework argues that magnetic monopoles are not physical particles that possess a fundamental magnetic charge.
If they aren't particles, what are they?
They are topological phase singularities. Let's return to our vortex ring, our spinning quantum donut. In fluid dynamics, a vortex doesn't have to form a closed loop. It can be a line, like a tornado touching down.
Right.
The monopolar is literally just the endpoint of a vortex line in the complex Higgs order parameter.
The Higgs order parameter being the mathematical description of the vacuum fluid's structure.
Exactly. At the exact center of a vortex line, the fluid is spinning so fast that the mathematical phase of the vacuum becomes undefined. It is a singularity. When a vortex line has an endpoint, that endpoint acts as a physical source or sink of the spatial curl.
Let me break this down visually. Picture blowing a smoke ring. That perfectly closed donut is our glue ball. It's stable, it floats across the room. Now imagine taking a pair of scissors and snipping that smoke ring in half.
Okay.
You now have a line of spinning smoke with two broken ends. Those two ends, the broken tips of the torn vacuum tornado, those act as the magnetic monopolars.
That is a highly accurate visualization. In the mathematics of the framework, the magnetic field maps directly to the spatial curl of the vacuum phase gradient. Where the phase slip line terminates, the snipped ends of your smoke ring, the curl must mathematically diverge.
It breaks the math.
Yes. It creates a point that looks exactly like a source or a sink of magnetic flux. Macroscopically, it manifests as a Dirac monopole.
And this solves the decades-old paradox of why we can never catch a monopole in a jar. Physicists keep looking for a standalone fundamental particle, but you can't isolate the end of a vortex without the rest of the spinning vortex attached to it.
You really can't.
It's like trying to harvest the end of a string without taking the string itself. The monopole isn't an independent resident of the universe. It's a geometric boundary condition of a broken vacuum defect.
It resolves the mystery simply by changing the geometric interpretation of the phenomenon. Monopoles are just features of the vacuum's topology.
Okay, so during this violent vacuum freeze in a collider, we get messy cracks, which are the tetraquarks. We get perfect donut tornadoes, which are glue balls. We get the broken ends of those tornadoes, which manifest as monopoles. We have vortex rings and vortex endpoints. But what happens if the defect isn't a spinning vortex?
That's a great question.
What if it's just a stable, localized lump of density in the vacuum fluid? Because the Banić papers state that this specific type of defect holds the answer to arguably the biggest mystery in modern cosmology.
We are transitioning from the microscopic scale of particle colliders to the macroscopic scale of galaxies here. We are talking about dark matter.
Dark matter?
In standard cosmology, normal matter stars, planets, you and me makes up only about 15% of the mass in the universe. The other 85% is dark matter.
We know it's there because we can see its gravitational pull holding rotating galaxies together and bending light around galaxy clusters. But it is completely invisible. It doesn't emit light, reflect light, or block light.
For decades, the dominant theoretical candidate for dark matter has been WIMPs, weakly interacting massive particles. The assumption was that there must be an invisible, ghostly particle flooding the universe.
Right.
But despite billions of dollars, decades of research, and incredibly sensitive detectors buried deep underground in abandoned mines, we have never found a single confirmed WIMP.
Standard physics is at a total impasse. They know the mass is there, pulling on the stars, but they can't catch the particles they invented to explain it. How does the Redefined Mass framework solve the dark matter problem?
It offers a brilliant, non-trivial solution that bypasses the need for WIMPs entirely. Postulate 11 of the framework states that dark matter is comprised of neutral, charge-free, phase-density solitons of the Higgs VeV.
A phase-density soliton. Let's unpack the word soliton. In fluid dynamics, a soliton is a stable, localized wave. There is a famous story from 1834 of a Scottish engineer named John Scott Russell who watched a canal boat suddenly stop.
I know this story.
Yeah. The water pushed in front of the boat formed a single, rounded wave that rolled down the canal for miles without losing its shape or flattening out. That single stable lump of water, is a soliton.
That historical observation is the perfect analog. Now apply that phenomenon to the superfluid vacuum of the universe. A dark matter soliton is a stable, localized fluctuation, or a lump, in the density of the background Higgs order parameter.
Okay, a lump in the vacuum.
Yes. In the math, this density lump is represented by delta n. Crucially, because the Higgs VeV inherently possesses a non-zero energy scale, this density fluctuation carries a real, localized packet of extra energy, denoted as delta E.
And this brings us back to one of the most famous equations in history, E equals mc squared, and this framework's postulate 10. Energy and mass are deeply physically connected.
Yes, they are. Postulate 10 dictates that physical mass is comprised of field self-energy. Because the soliton is a localized packet of highly dense vacuum energy, it essentially possesses a virtual mass.
A virtual mass.
And because it has mass, it bends space-time. It couples gravitationally to the rest of the universe.
So it has mass,
Yeah.
and it exerts a gravitational pull. But why is it invisible? Why doesn't it interact with light?
This comes down to the coupling constants of the universe. Standard matter, like the protons and electrons in a star, has an electric charge. Because of that core charge, denoted as Q, standard matter couples to the electromagnetic field via the fine structure constant.
Okay.
This standard electromagnetic interaction scales with the square of the elementary charge, E squared. Because it has charge, it can absorb, emit, and reflect photons. It interacts with light.
But the dark matter soliton is just a lump of the vacuum itself.
And the vacuum is neutral. The dark matter soliton has a net electric charge of absolute zero. Q equals 0.
Oh, I see.
Because it lacks an electric charge, it is completely 100% decoupled from the standard E squared electromagnetic sector. It physically cannot interact with a photon. However, the Banić papers introduce a specific fourth-order electrogravitational coupling constant, mathematically denoted as E to the fourth.
She to the fourth.
The neutral soliton interacts exclusively through this much weaker fourth-order gravitational coupling.
The elegance here is stunning. Dark matter isn't some ghost particle that we can't seem to catch in a detector. Dark matter is literally made of the Higgs field itself. It is just the background fabric of reality bunched up.
It is a profound paradigm shift. Dark matter is the background medium of the universe, rippling and bunching together into massive, invisible waves.
Let's use a visual to lock this in for you listening. Imagine a large, heavy rug covering a floor. The rug represents the Higgs superfluid vacuum. Now imagine a speed bump placed under the rug.
A speed bump under the rug.
Yeah. If the rug is completely uniform in color and you look at it from above, you might not easily see the speed bump. It doesn't have a different color or charge to reflect light differently than the rest of the rug. It's a phantom density.
Exactly.
But if you roll a heavy marble across the rug, the marble will curve and alter its path as it rolls over the bump. You can observe its gravitational effect, its mass, even though you can't see the bump interacting with light.
This completely reshapes our understanding of galactic dynamics. Astrophysicists know that galaxies are rotating so fast that the outer stars should be flung out into deep space. The standard model assumes these galaxies are embedded in a massive sphere of invisible WIMP particles holding them together.
Right, a halo of particles.
But under the Banić framework, galaxies might just be surfing on giant, stable density riffles in the superfluid vacuum itself. The vacuum is not an empty stage where physics happens. The vacuum is the structural scaffolding of the cosmos.
It is a breathtaking theoretical framework. I mean, it connects the crushing of a proton to the rotation of a galaxy. But I know what you're thinking right now. This is all beautiful math. The analogies are cool. But where is the proof?
Truth is essential.
Theory is just philosophy until it is backed by observation.
Yeah.
You can't just claim that protons collapse into 1D strings and vaporize the vacuum without some hard experimental evidence. Where is the real-world proof that 3D particles actually undergo this relativistic string transition?
It is the essential question for any new theoretical framework, and the Banić sources do not shy away from it. They cite specific, observable proofs, grounding the theory firmly in experimental data. They outline two distinct types of evidence, one terrestrial and one astrophysical.
Let's hear the terrestrial one first.
Okay, first let's look at the terrestrial proof. They detail the silicon crystal dechanneling test.
The dechanneling test. I'm somewhat familiar with crystal channeling and particle physics, but walk us through how this proves the string collapse.
In high-energy particle physics, channeling is a well-documented phenomenon. You take a beam of charged particles, like electrons, and you fire them into a perfect crystal lattice, in this case, high-purity silicon.
Okay.
A crystal lattice is highly structured. It has repeating atomic planes with microscopic corridors or channels between them. If the electrons are standard 3D spheres, their interactions with the repeating atomic walls follow very predictable classical scattering patterns.
Right. It's like firing a handful of tennis balls down a long, narrow hallway. You know roughly how they are going to bounce off the walls and at what angles they will eventually exit the hallway.
Exactly. The mathematics of 3D scattering in a crystal are deeply understood. However, the Banić framework predicts that if you accelerate that beam of high-purity electrons to ultra-relativistic velocities, they will undergo the transverse boundary collapse we discussed earlier.
They turn into strings.
They will flatten from 3D spheres into 1D physical strings.
And a string bounces down a hallway very differently than a tennis ball.
Fundamentally differently. A one-dimensional string, aligned with its axis of motion, will interact with the narrow channels of the silicon crystal lattice in a way that breaks standard 3D scattering models.
It breaks the models.
Completely. The angles at which they scatter, and specifically the rate at which they dechannel, meaning they escape the atomic corridors and cross the lattice planes, alters drastically. Their geometric profile has collapsed from a sphere to a 10 to the negative 18th meter thin needle. The physical interaction footprint changes entirely, and this altered dechanneling rate can be physically measured in a laboratory.
So we can literally fire them into a silicon crystal and measure the geometry of the holes they punch on the other side, proving geometrically that they have collapsed into needles. That is an incredibly clever, testable prediction.
It's very elegant.
But the papers go even further. We started this deep dive inside a particle accelerator, looking at subquantum limits of 10 to the negative 18th meters. Then we looked at the massive scale of galactic dark matter. Now, for the final piece of evidence, we are looking at our own solar system. What is the astrophysical proof?
The sources cite the anomalous solar disk gamma-ray excess. For years, astrophysicists using space-based telescopes have observed inexplicably high-energy gamma rays radiating directly from the solar disk of our sun.
From the sun?
Yes. Our standard models of solar fusion and standard magnetic field interactions struggle to fully explain the origin, the spectrum, and the extreme intensity of these ultra-high energy bursts.
So the sun is doing something that textbook physics says it shouldn't quite be able to do. How does the redefined mass framework step in and explain it?
By applying the string shatter and relaxation dynamics directly to solar plasma physics. The sun is not a calm, uniform ball of gas. It possesses extreme, highly complex, and chaotic magnetic fields, especially near its surface during active periods and solar flares.
Okay.
When standard protons in the solar plasma are caught in these intense local field gradients, they can be violently accelerated to ultra-high velocities.
So the sun is acting like a giant natural particle collider.
It is. As these solar protons accelerate, they generate that intense azimuthal magnetic pressure we talked about. They undergo the transverse collapse. They flatten into 1D relativistic strings right there in the solar plasma.
But the sun isn't a clean, empty beamline tube like the Large Hadron Collider. It is a chaotic mess of competing magnetic fields.
Which is exactly why the strings don't last long. These 1D strings are highly unstable in the dense, chaotic plasma of the sun. They are rapidly deflected or violently decelerated by surrounding opposing magnetic fields.
And we know what happens when they decelerate.
We know from the collider math exactly what happens when a tension string violently decelerates.
The elastic snapback.
The snapback. The 1D string instantly relaxes back into its natural 3D spherical proton state. As it expands transversely back to its normal 3D geometry, it sheds that massive dimensional reduction energy pool.
It releases all that energy.
The magnetic pressure that was trapped as tension is violently released into the surrounding solar plasma.
Let's visualize this one more time. Imagine a heavy-duty steel spring. You compress it down as hard as you can, storing all that potential energy. The proton is a compressed spring of magnetic pressure.
Right.
When the proton is suddenly slowed down by a rogue magnetic field in the sun, the pressure drops. The spring expands violently, and it shoots out a blast of pure, high-energy radiation.
The framework specifies that this release manifests as a highly anisotropic, ultra-high energy gamma-ray burst. Anisotropic meaning the energy does not radiate equally in all directions. It is highly directional, focused by the geometry of the expanding string.
And do the numbers match the mystery gamma rays we actually see?
The mathematical derivation in the sources is exact. They calculate the specific frequency of these massive deceleration bursts, which they term the prompt focus, to be exactly 2.66 times 10 to the 22nd hertz.
2.6 times 10 to the 22nd hertz.
This specific, mathematically derived relaxation burst frequency directly correlates with the anomalous high-energy gamma rays observed coming from the sun.
That's amazing.
The Banić framework provides a direct, verifiable electrodynamic mechanism for a cosmic mystery that standard physics has struggled to explain for years.
That is just, staggering. We are talking about an insane amount of energy coming from a single proton snapping back into its 3D shape, and that makes you wonder about the rest of the universe.
It really does.
If this is happening in our relatively quiet, medium-sized sun, are these string relaxations happening everywhere? Think about the extreme deceleration occurring around the accretion disks of supermassive black holes or inside the shock waves of supernovae. The entire cosmos could be glowing with the high-energy light of collapsing and expanding proton strings.
It is a highly compelling extrapolation. If the fundamental geometric stability of matter is truly dependent on velocity and magnetic pressure, then extreme astrophysical environments across the universe are constantly forcing matter to undergo this phase transition between 3D spheres and 1D strings.
Wow.
The intense gamma-ray background of the universe might simply be the ambient noise of a trillion strings snapping back into shape.
This has been a truly mind-expanding journey. Let's take a breath and summarize the ground we have covered today. We started with a simple proton, but we learned that its physical boundaries are not hard walls, but a dynamic balance of forces. We explored how that proton gets flattened into a one-dimensional physical string by its own magnetic pressure as it approaches the speed of light. And by giving that string a tiny physical width of 10 to the -18th meters, we saw how it completely eliminates the mathematical need for string theory's invisible extra dimensions.
We then explored the violence of high-energy physics. We observed those strings shatter in high-energy collisions, momentarily vaporizing the localized Higgs vacuum and generating a Higgs-symmetric plasma thousands of times hotter than the core of a star, restoring the vacuum to a massless phase.
And as that massless plasma rapidly cooled, we watched the quantum vacuum flash freeze and crack, nucleating topological vacuum defects. We completely redefined the particle zoo. We saw tetraquarks as complex nested vacuum bags, glue balls as pure vacuum smoke rings whose tensor mode mathematically perfectly matches a mass of 2.48 GeV.
Perfect match.
We saw magnetic monopolas not as independent particles, but as the broken ends of those torn vacuum tornadoes. And perhaps most profoundly, we reframed dark matter as invisible, massive density solitons in the vacuum fluid itself. All of it proven by watching electrons slip through silicon crystals and mapping the 2.66 times 10 to the 22nd hertz gamma ray bursts of our very own sun.
It is a theoretical framework that takes the invisible and the abstract and makes it vividly mechanical. It suggests that the universe is not a collection of disparate, disconnected particles floating in a dead, empty space, but rather a single, continuous, highly dynamic fluid.
Which leads me to this final thought. I want you, wherever you are listening right now, to really mull this over. If this redefined mass framework is correct, if all matter, the protons in the device you were listening on, the exotic particles briefly born in colliders, and the dark matter holding the Milky Way galaxy together are just varying ripples, geometric defects, and compressed states of a single underlying superfluid vacuum, then you are not just a creature existing in the universe.
You are quite literally a complex, self-sustaining knot tied out of the fabric of the universe itself.
A complex knot of the vacuum. Thank you for joining us on this incredibly deep dive into the redefined mass framework. Never stop questioning the foundational fabric of reality, and we'll catch you next time as we continue to explore the absolute edges of human knowledge.